Hi, we'll be going over how to look at differential calculus questions for our paper 1. Question asks you to give the derivative using the first principle. This is the equation that they want to use. This here would be the original equation, and then that one would be the original equation plus h. And then we have to simplify. When we're done simplifying, we're going to equate h is equal to 0, so that you can if they don't ask with regards to the first derivative, we can use the rules that we have over here. Rule 1 says if you want the derivative of a to a x to the power of n, are we going to do to drop the n and then minus 1 from the n. Let me give you an example. We also have here special cases where we have 8x and the derivative would just be a constant, and the derivative of a constant is equals to 0. So the derivative of an equation will give us the gradient of the tangent line to that equation. So here we're going to look at how to solve for the equation of a tangent line. So, and in this case, here's the equation we're using, and in this case is gradient x1 and y1 are coordinates of the point. So it's either they're going to give you the gradient or the point, even if they just give you the x value. So if they give you just the x value, we need to substitute the x value into the equation to get the y value, and therefore getting the point x1 and y1. Then you're going to derive your equation, and then you're going to substitute the x value into the derivative so that you can get the gradient. And therefore you have your gradient and your point, and you'll be able to calculate for your tangent line. Let's look at the graphical interpretation of the derivative that we're finding. So for the first derivative, we're going to be able to establish whether we have an increasing or a decreasing graph. If the derivative is positive, then we have an increasing graph. The increasing could either look like this or look like that, either way is increasing. If our second derivative is negative, it means that we have a decreasing graph. The decreasing graph can look like this, or it can look like that. If our first derivative is 0, then we have what we call a stationary point, and you can see that it's not, we don't have a tangent line because it's not. We also have the second derivative. The second derivative will tell us whether our graph is facing upwards or facing downwards. If our second derivative is positive at a certain point, then we can say that the graph is concave. And if the second derivative is negative at a certain point, then we can say that it is concave down. We also have a point of inflation. A point of inflation is where the graph changes from concave up to concave down, and we can find this x value of it by equating our second derivative to 0, and then finding the x value of that. That x value we substitute into y, and we substitute it into our f of x, and then we can get that y value. Okay. So we can also find local minimum and maximum. If our first derivative is equals to 0, and our second derivative is positive, then we say that we have a local minimum. If our first derivative is equal to 0 and our second derivative is less than 0, then we will have a local maximum. We can also have a stationary point of inflation. A stationary point of inflation is when both the first derivative and the second derivative are equal to 0. They can either look like this or look like that.